Hey guys, I want to say thank you so much for stopping by the channel today. We got a great lab for you today. Today we're going to be working on a BGP environment as well as an OSPF environment. We're going to configure a BGP environment to simulate an ISP infrastructure. We're going to configure a multi-tiered enterprise environment with multi-homing. So we're going to configure it to have two different ISPs for redundancy. We're going to do some traffic manipulation in order to prioritize the primary ISP and have the secondary ISP for backup and redundancy. We're also going to do some address summarization and route redistribution from OSPF into that BGP network. So we're going to cover all that and more in this lab. Let's get started. What's up, guys? Welcome to the lab today. I initially wanted to do this lab all in one video, but I quickly found out that it would take forever. It'd be a very long video. And so we're going to break it up into segments. And so in this first segment, we're going to get this BGP network running. So we are simulating a multi-homed enterprise environment. And so we have two OSP routers connected to an IP exchange router connected out to a NAT interface to give us internet connection within our lab topology. And so when everything is done and configured and traffic is flowing the way that it should be, we should be able to reach out to the internet with our client devices. But that's in the future. A couple of things that we're going to do in this lab. We're going to, like I said, first thing is get this BGP network up and running. And down to our core level routers, we're only going to be running BGP on one interface apiece in order to peer with our ISP routers. And we only want the BGP network to pass the default route down to our core routers. We don't want to know about everything that's going on the ISP side. We just want to know the default route. And so we're going to configure some and also another thing, whenever we get all that configured, we're going to want to manipulate the metrics a little bit in order to prefer, whenever data leaves our network, we want it to prefer the link between core router 1 to ISP router 1 to IXP exchange router. And so that's what we're going to be looking at in the future. So we're just going to configure some OSPF metrics on here to kind of force our network to prefer this route. But before that, that's all in the future. Before that, we got to get this BGP network up and running first, and so we haven't configured anything yet. So these devices are all brand new, zero configurations, and so we can go ahead and get started with this IXP exchange router. And so first of all, we're going to want to go ahead and we're going to want to open the G00 interface to have that connection with the NAT interface. So we're going to say interface G00 and assign it an IP address of 192.100.15. This is a /24 mask, and we're going to say shut to go ahead and open that interface up. And now we're going to want to go ahead and configure our default route. So we're just going to say IP route. And we want the next hop to be the virtual NAT interfaces default gateway. So, and that address is going to be 192.168.100.2. All right. And so let's do show IP. So, all right, this interface is up and it has an IP address. So let's go ahead and try to do ping. See if we can reach out to the internet from here. And it looks like we can. So we're good to go there. All right, now let's configure the rest of these interfaces. So we got interface G00, interface G00, and on this interface we're going to configure the IP address to be 172.16.4. This is going to be 1. This one's going to be a /30 mask, and we're going to go ahead and open it up, no shut. Also, we're going to do interface G20. This is the link between the IXP exchange router and ISP router 2. And we're going to say IP address for this one to be 172.16.5.1, and that's also going to be a /30. And no shut, open that up, verify everything. Alright, what did we miss? Interface G10. How did we skip that one? Alright, I thought we... Oh, no. So I'll reconfigure. That's how I miss it. So let's go back to interface G00 IP address 192 dot okay, now interface G10. So in my topology, I should have fixed that, guys. So I just kind of glanced over here and saw the G00, and in my mind, I didn't really see which interface that it was referring to. So I'm just going to go ahead and move this up here so it doesn't get confused again, and keep this here for G10. All right, or we'll move it over here. It looks better over here, I guess. That's where my mind saw it in the first place and got confused and reconfigured G00. And so we're going to say interface one. This one's going to be 172.16.4.1. Oops. All right, and no shut. Now let's see if we've got it right that time. So yep, looks like we got everything good and assigned. Since I had to reconfigure that 00, let me see, do ping. Okay, all right, we're good there. Got everything fixed. Now we got all the interfaces configured, open with IP addresses. Let's go ahead and start this BGP instance. So this is going to be router BGP. This is going to be autonomous system 65050. And here we're going to say establish a neighbor relationship with, it's going to be 172.16.4.2 is what that one's going to be. And that's going to be remote. Autonomous system 65010. And we want to advertise that route. Place this route in our BGP table, so 172.16.4.0 mask. What did we miss? Oops, I said neighbor instead of network. That's it. And we're going to do type today, guys. Neighbor relationship between 172.16.5. That's going to be 5.2, and that's going to be on remote autonomous system 65020. And we also want to advertise that network. So okay, so let's look at our BGP table, and these are the networks that we're going to be propagating to our BGP network from this router. And exit here, exit here, and move on to ISP router 1. All right, on ISP router 1, same thing. Let's go to, we did forget something on ISP exchange router 1. I'm gonna go back real quick. I did forget to do, let's go going, see, you could do this a couple of ways. I've tried to do the redistribution utilizing a prefix list and a route map, but for some reason I cannot get it to work on this version of iOS. I don't know if it's because it's kind of a virtual iOS, or it's just not working correctly in GNS3. But even then, when you want to redistribute this, see, do show IP route. So we have a static default route here. And so in order to propagate this default route throughout our BGP network, we have to redistribute it from a static route into a BGP route. But there's different ways that you can do that. You could use the default originate. So that command would look like, from BGP configuration mode, you would say neighbor, just say 172.16.4.1, and you say default originate. But that you would have to configure the default originate for each segment. Another way that you could do it would just be to advertise a default network. So like that. And so that's what we're going to do, so that it automatically pushes out to everything. And so we should be able to see once we form. All right, let's say show. All right, so yes, we are sending it out here, and we're going to go back over to our ISP router 1. Let's get this configured. T interface G20. Check again, make sure I am configuring the right interface. They get kind of bunched up on this this topology sometimes, guys, and it's easy to mistake. So it's good to slow down, take your time, make sure you're doing what you need to be doing. So IP address for this one's going to be 172.4.16.4.2, and this is going to be a /30. No shut. And we're also going to do interface G00. IP address for G00 is going to be 172.6.1.1. Shut. Also going to be configuring interface G10. IP address will be 172.16.2.1. This is the link between ISP router 1 and core router 1. And we're going to say no shut. And just verify those interfaces do show. All right, so we got 3 interfaces, assigned IP addresses, and they are up. And let's get right into, this is going to be autonomous system 65010. And on this autonomous system, we're going to have a neighbor relationship with 172.16.4.1. That's going to be on remote autonomous system 65050. Should see a neighborship form here in just a second. We're also going to do a neighborship with 172.16.1.2. That's going to be on remote autonomous system 65020, and neighbor 172.16.2.2. system 6.0.0.1. Okay, and for the networks that we want to advertise from this router, it's going to be either 172.16.1.0 with that /30 mask, and also the 172./30 mask. All right. Let's see. BGP table. All right, so we are advertising this network from these are the ones we are advertising locally, and these are the ones we're receiving from the ISP exchange router. All right, let's get over to ISP router 2. So I'm going to run through these real quick. It's getting kind of repetitive here, guys. So interface G20, the address. I'm ahead of myself. All right, got those configured and up. The only network that we want to advertise from this one is the 172. We'll also advertise the link between ISP exchange router and ISP router 2, or ISP router 2, yeah. So, okay, BGP table's getting a little big. We can also look at some, check out some route summaries later as well. So, but we'll just do it like that for now. All right, moving on to core router 1. Core router 1, we only have one BGP link, so we're just going to say 0, 2. Alright, we got our default address. So we also have all these right here, but we're going to filter those out here in just a bit. And finally, core router 2. Say HG0 as well. IP address is going to be 172. All right, 65001. Neighbor with 172. Waiting on that neighborship to form. There we go. Neighborship is up. C. Let's go ahead and exit this. Show. All right, we got our default route and several others that we're going to filter out. All right, guys, we got all that formed. In our next video, we're just going to go through the configurations to filter out these routes that we do not want passing down to our core level routers. All right, guys. All right, guys, in this section, we're going to apply some route maps to our ISP routers in order to filter what we want to advertise via BGP to our core level routers. And so if you look on our core level routers now, we can say show IP route. So we're getting all these routes from BGP that we do not want to see here. The only thing that we want is this. And so a good way to do that, let's just check router 2. Yep, same thing. All right, so yeah, the only thing we want is this default route. And so the way that we can do that is to create some prefix lists to filter out just the default route and apply those prefix lists to a route map and apply that route map to this link in order to only the only thing we want coming out of these ISP routers as far as BGP routing are the default routes. So also I forgot to test in our last section. I forgot to test to see if we had internet connectivity from our core level routers, which we definitely should. Let's so let's say ping. All right, yep. So that's good. And let's just get started on ISP router 1. I'm going to say conft, and we're going to do IP prefix list. We're going to name it default route only. And we're going to call it, give it a sequence of 10. I'm going to say permit /0, and we don't want, this is all we want. So like access lists, prefix lists have a what you call it, a implicit deny, and so if it's not directly listed in this prefix list, it's automatically going to deny it if it's not told to do otherwise in a lower sequence. So we're just going to go ahead and hit enter on that. And so that's our prefix list that we're going to utilize, and then we're going to say route map. And this is, we're going to name it advertise default route. And I think you give it a, I'm going to say permit, and I think you give it a sequence number as well. Yeah, so we're just going to say 10. And here we're going to say match IP address from, should be per, yep, prefix list here. And then we're going to name, we named our prefix list, what did we name? Default route only. So default route only. And that should be it. So we got our prefix list and our route map for ISP router 1. And so now we're going to go into router BGP 65010, and we're going to say neighbor 172.16.2.2, and we're going to say route map, and then we're going to apply the route map we just made, which is advertise default route, and then we're going to apply that out. So anything that, the only thing that we're going to push out is the default route, and we're going to filter everything else. So enter on that, exit, and then we're going to say, I'm going to verify this. It might take a little bit to update, but let's see. We're going to say show IP BGP neighbor 172.16.2.2 advertise routes, and so it's not advertising anything. Let's go back up and let's see show IP BGP, or let's say show run. All right, so yep, and it applied here. Let's look at show. Let's see, maybe it took a second. Okay, yeah, it just took a second. And so now we're only advertising our default route to our top level core routers. And so we're just going to do the same thing on ISP router 2. Click over here. So on ISP router 2, we're going to make that IP prefix list I'm gonna name it, I think we named it default route only sequence of 10. That's going to be 0. Oops, we forgot something. What did we forget? Oh, permit. Permit. All right, good to go. And then I'm going to make our route map. I'm going to call it advertise default only, and permit 10. And here we're going to say match IP address from prefix list, and that prefix list is default route only. All right, and now let's just apply our route map to E0 to 0. So we're going to say neighbor 172.16.3.2 route map advertise default only out. All right, let's give it a little bit, give it a few seconds. Show IP BG. Neighbor. Not yet. All right, there we go. All right, so we are only advertising our default routes to our core level routers. And let's just drop down to our core level routers, say show IP route, and that's it. We're only getting those. We're only getting our default routes from BGP. So good deal. Let's check on router 2. Route. Yep, same thing. And that's it, guys. So that's how you filter traffic or filter which routes you want to flow on BGP. All right. All right, so in this section, we're going to be configuring OSPF and OSPF area 0. Let's just get started on core router 1. So let's say show IP. All right, the only interface that we've configured so far is gigabit 00. So let's go ahead and get the other interfaces configured. So T 10, the address 10.1.0.1, and we've got interface G30. IP address is going to be 10.1.2. We've got interface G20. Address is going to be 10.1.1.1. 10.1.1.1. think that's it. Do show. All right. 4 interfaces up and assign IP addresses. So router OSPF 1 network. We want to advertise 10.1.0 networks with a /30 subnet mask, and that's going to be in area 0. So in OSPF, OSPF utilizes a wildcard mask. So if you're not familiar with a wildcard mask, it's just the inverse of a subnet mask. And so a good way to find out your wildcard mask is to take your subnet mask and subtract it from a network address containing all 255s. So you would have 255.255.255.255, and in this case, as a /30, we would subtract 255, 255, 255, 252 from that, and that would leave us a 0.0.0.3 wildcard mask. So we got that network, and we're going to do network 10.1.1.0, and we have network 10.1.2. 0. All right. All right, we got 3 OSPF links, and we have 3 configured here, so that looks good. All right. So nothing fun happening so far, but let's jump over here to core router 2. And let's open up all the interfaces on it as well. So T interface G10. P address is 10.1. This is going to be 2. Shut. And interface G30. Address is going to be 1. Shut. We have interface G20. That IP address is going to be 10.2. Four links connected and 4 links configured. Exit. And let's advertise network 10.2.3. Don't have any OSPF neighbors yet. Select core 1. Oh, yeah, we have a neighborship now. So that should show here. Show IP OSPF. Let's get out of here. Okay, all right, we got that neighborship formed with core router 1. That's the route. That's the router ID. So the router ID is going to automatically took that. You know what? Let's go ahead and reconfigure that. So let's say conft router OSPF process 1. And let's just do a router ID scheme. Since this is core router 1, so we'll do 1.1 core and 1 core router 1. Reload or use clear IP OSPF process command for this to take off. So let's say do clear IP. Alright. That should have fixed that. And let's do the same thing on core router 2. Let's go ahead and say conft router OSPF 1 router ID. This is going to be core level router 2. Oops. Let's do that again. Okay. Now let's say do show. Cool. Now that looks a little bit better. All right. Now on to access router 1. I'm going to go over here and close a couple of these out, these ISP routers. Let's see what we're working with over here. I haven't configured anything on ISP router 1 yet, so we're going to say interface G00 IP address. It's going to be 10.1.1.2. And another way you can do this, guys, is IP OSPF 1 area 0. So we can establish OSPF right in the interface itself. So for area 0, +1 failed to allocate unique router ID. Not. Oh, I gotta do that router ID. You know what? Let's just go ahead and do that real quick so that we can just go ahead and do those OSPF configurations in the interfaces themselves. So let's exit here, go to router OSPF 1 router ID. And so since this is access layer, we're going to say 2.2. This is router 1, access router 1. All right, let's use that. Exit back to interface G00. And let's run this again. All right. So we should have an OSPF neighborship formed with core router 1 now. So interface G10 IP address going to be 10.0.10.1. Oh, we didn't It's not going to form because we didn't open the interface. So back up to interface G0. And so we're also connected over here on G20, but we're going to hold off on that for right now. And whenever we establish OSPF Area 1, because we've got several things to configure here. We've got some logical interfaces in order to facilitate the different VLANs and subnets. And in this OSPF Area 1 network, we're also going to configure DHCP to automatically assign IP addresses to our edge devices. So we've got a lot to do when we get down here, so we're going to hold off on that interface for now. And I'm going to say do show IP OSPF neighbor, and we do have that full neighborship with core router 1. Let's exit. Let's show. So we got these two. We're going to hold off on G20 for right now. We're going to do that in the next, or in an upcoming section. And I think we're done there. So let's move on over to access router 2. All right. So first thing we're going to do on access router 2 is run router OSPF 1. Router ID, this is going to be access layer router 2, it's 2.2.202, and exit, so interface G00, IP address is going to be 10.1.2.2. And we're going to say IP OSPF 1 area 0 and no shut. And interface G20. Say IP address 10.0.10.2. IP OSPF 1 area 0. No shut. Okay, and say to show IP. So we have left. We've done 2.0. We've done 0.0. We have to do 1.0 and 3.0. So G IP address. This will be 10. G30 IP address. It's going to be 10.20.0, or I'm sorry, 20.1. Again, we do have G40 on access router 2, but we're going to hold off on that until a later segment. And now access router 3. So very repetitive here. We want to get through these real quick. So conf T. know why I keep missing my slash today. 00 to say IP OSPF area 0. Then we're going to say oh shit. Oop, we forgot our router ID here. So exit router OSPF 1 router ID. So this is going to be access layer router 3. And now say do exit. So we've done 0 so far. Have we? Okay. Two-way state. Okay, there we go. Now it's full. You can say all right, interface G1 0 IP address. All right, a lot going on here, a lot of routes from OSPF. All right, so looks like we're good on our OSPF area 0 configurations. Our next configuration is going to be to we're going to redistribute that BGP default route into our OSPF network and also add some metrics to it so that we can prefer sending our data out of core router 1 and let core router 2 peer with our failover ISP. And so this is what you could typically see in an enterprise network where the enterprise network has two different ISPs. You got one main ISP and then one failover ISP for redundancy. And so typically by default we want all of our traffic to go out of this link and have this link as a backup. And so we're going to hop on that here in this next section. All right, guys, so in this segment we're going to work on getting our default route down from our BGP network into our OSPF network and get it advertised throughout. Another thing that we're going to cover in this segment is getting our information from so right now whenever we send information or send data out of our OSPF network into our BGP network, the BGP network does not know how to send it back. It does not know where to go. And so we're going to advertise route summaries from our BGP net or from our OSPF network to our BGP network, so that whenever we need things returned like a trace route, we can the BGP network will know exactly what to do with that data. And so let's go ahead and get started on core router 1, and we're going to say router OSPF process 1, and we're just going to say default information originate, and we're going to say metric because we want it to prefer the link from core router 1 to ISP router 1, and we want to use this as a backup. So metric is, we're just going to say 0, and metric type, we're going to say 1. And so in OSPF you have two different metric types. You have metric type 1, which aggregates the cost as you move across the OSPF network. So as you move from router 1 to router 2, it adds costs. As you move from router 2 down to access router 3, it adds the cost. And so, but if you would do metric type 2, it doesn't. So if you set metric type 2 and set the metric, then that's what the metric is throughout the network. It does not aggregate cost across the network. All right, so we're just going to say 1 and exit. Now we're going to go down here and look at access router 3. So we're going to pay particularly close attention to access router 3 throughout this segment's configuration, because access router 3 is in a unique position. It's the farthest node from our preferred gateway for our OSPF network, and it's closest to the one that we want to avoid unless we need it. And so with access router 3, we're going to have to do a little bit of manipulation in order to get it to route like we need it to. And so now we're just going to show IP route, and we can see that now we do have a default route. But the thing is that we have two different routes. So we have two different ways to get to core router 1. And we'll deal with that in just a bit. But for now, let's just hop on core router 2 and do the same thing. I'm just going to say T router default information originate, and we're going to say metric. Let's say metric 10, and we're going to say metric type 1 as well. And so there we go. Now let's look back at access router 3 and see what we're looking like. We're going to say show IP route. And so we're still pointing at core router 1, but the thing about it is if this information gets sent up to core router 2, it's going to get caught in that, and it's going to send it straight out of its BGP default route. So we don't want it to do that. We want to look. I'll show you. For instance, say we want to. Well, we'll have to configure our route summary first before I'm able to successfully do that. So I would like to show you that. So we're just going to go ahead and configure these route summaries real quick. So we're just going to say back into router BGP, or I'm sorry. Oh yeah, we do need to go into BGP 65001, and we're going to say redistribute OSPF. I think it's process ID 1, and we're going to match internal and external 1 and external 2. So type 1 and type 2 and internal. So we're going to match all those so that we match everything that comes out that can possibly come out of OSPF. And we're just going to hit. What did we miss here? Yeah, okay, I misspelled external. All right, now we're going to say aggregate address. And so first off, we're going to do our 10.0.0. We're going to, like, all of our links are in the 10.1 or 10.2 subnet here in our OSPF area 0 network. And so we're just going to advertise a 10.0.0.0 slash this aggregate mask. So that's going to be a /8 network. Let's see what else it asks for. Summary only. And that's it. So we're going to advertise that, and then we also have this access OSPF area down here that we're going to go ahead and set up for that. So all the subnets in it that you can see are within a 192.168.0.0 network, and so we're going to configure that to, well, you know what, we might be better off to because we might run into a problem with the NAT network up here up top. So there might be a conflict there. So we'll have to see about that here in just a bit. Yeah, I'm thinking there probably will be a conflict there. So we can just go ahead and try a say 192.0 only, and exit. Now I want to go to ISP router 1 and check the routes and see if that 198 actually took. So do or show IP route. Okay, so yeah, we summarized the 10.0.0.0/8 network, but it did not summarize the 192.168/16 network. And so there's going to be a conflict there. We might have to rethink our addressing scheme here in this if we want to summarize that, or we may just come up with a better way to do that. So we'll see. We may have to I don't know, we'll figure it out when we get there. But for now, let's just look at our, so yeah, back here to router or access router 3. I wanted to show you, let's do a trace route now that we can find our way and find our way back to the ISP exchange router. So it's a 192.168.100.15. And so here we have a whole bunch of stuff going on. So there's no like very crisp, very straight route to where we want to go. And so we don't want that, because even here we're going out of we're going out of the interface that we really don't want to go out of, core router 2. And so we don't want to use core router 2, so we just want to use core router 1. And so to do that, though, we're just going to go back to core router 1. You can do this a number of different ways. With the metrics that we've set, every other route is going to prefer core router 1, and you won't have to worry about it running into core router 2. And so the only thing that we really have to change here, we can make one configuration and fix this, so we can go and access router 3, conf t, go into interface configuration mode, interface G00, and we can just say IP OSPF cost and just make it 10. And now we'll see that IP OSPF or show IP route. And so here now we have one way to get there. And as you can see, we can run traceroute again. Back to the ISP exchange router, and we have one straight, crisp, clear route. And so that's what we want to see. All right, so that's it for this segment, guys. We're going to move on down to our OSPF Area 1 network and try to figure out what we're going to do, how we're going to solve this problem of the address conflicts between our NAT network and our access OSPF Area 1 network. Alright guys, we have made it down to our access layer, and there are going to be several things that we configure here in this access layer, including we have some network segmentation, so we're going to be configuring some virtual interfaces on our access routers. We're going to be configuring VLANs on the switch. We're going to be configuring our access routers as DHCP servers to supply IP information to our edge devices. What else? I think that's it. So let's go ahead and get started with that. Starting on access router 1, let's say conf t, interface G20, gonna say no shut, then interface G2 0.10. Okay, this is going to be for VLAN 10, the sub interface. We're going to say IP address for this one's going to be 192.168 dot 10.0, or I'm sorry, 10.1 0. Oh, we gotta configure encapsulation first. Encapsulation .1q. The VLAN. So this would be 10. Now let's go back. Same thing. IP address. No shut. All right. Now we're gonna do interface G20.20. IP address 190.20.1. Oh, we forgot encapsulation again. We'll just go ahead and press enter. We know it's going to give the error, but VLAN 20. So we can do this. Say no shut, and we're going to go to interface G2 0.30 and say encapsulation .1q and 30 IP address 1.1. That's on that. So we got our sub interfaces are configured and good to go. And now, which way do we want to go? Move down. We can either down to the switch and get the VLANs subnetted, or just keep going with the routers and get all these virtual interfaces subnetted. I'll tell you what. So it's going to be very repetitive to get all these sub interfaces subnet it. So I'm just going to go ahead and subnet the routers, or get all the virtual interfaces up and running and get them subnetted on access 2 and access 3. And I'll get with you guys after I do that. All right. All right, we have got all of those virtual interfaces configured. We've got them assigned IP addresses. Now in this segment, we're going to just focus on getting OSPF configured for the access layer. So we've already got OSPF configured on our access routers. We just need to advertise these access layer networks. And so basically the 192.168.0.0/16 network, need to get it advertised up into OSPF area 0 and ultimately into our BGP network. But in a previous segment, we noticed that we were probably going to have an address conflict with our NAT network and the our access layer network. And so I figured the easiest way to fix that was just to go in and reconfigure that VMware virtual network to have a different subnet, so that we wouldn't even have a possibility of running into those conflicts. And so I just wanted to show you real quick. This might be a little bit off topic, but if you are new to networking, if you are new to lab environments, and you do run into an issue like this, you can always change these virtual network settings by going to your VMware window, going to Edit, Virtual Network, and down here, this is the network that we have our NAT cloud and GNS3 mapped to. And so you can just click on the NAT interface, and then you can click on Change Settings, grant it administrator privileges, and you can just change the subnet here, and you can change the subnet mask. You can also change the DHCP settings. You can also change the NAT settings here. And so one other thing real quick, if you have never worked with this system before, don't ever try to change this to 1, because it will not allow this NAT. The way this NAT virtual network is set up, it automatically assigns an IP address of .1 to the host machine, so it can communicate with the host machine. And so the gateway for this NAT address is always going to be a .2 or anything but .1 really. So if you do configure it to .1, it just the NAT virtual network will not work. So yep. All right, back on topic. Now we are going to start configuring our access routers to advertise the networks from our access layer. And so we'll just get started with that on access router 1. So we're just going to say configure terminal, router OSPF 1, and we're going to say first network is going to be 192.168.10.0 wildcard mask 0.0.0.255, and it's going to be in area 1. And again, network 192.168.20.0 wildcard mask, same thing, also area 1. Network area 1. All right, so we are advertising all these subnets from that were configured on access router 1. We're moving on to access router 2. And on access router 2, we're just same thing, conft router OSPF area process ID 1, and we're going to say network 192.168.11.0 area 1, and we're going to say network 192.168.21.0 and network 192.168.31. So that's advertising all the networks that were assigned on access router 2. And lastly, access router 3. And 68.13.0. 31. 23.0. Okay, now let's just do show IP route. And see if we're learning our other subnets. And yes, we are. We got 10 and 11 there, 20, 21 there, 30, 31 there. And this router is 33, 13, and 23. Okay, so we got our OSPF advertising our networks from OSPF Area 1. Let's just check out Core Router 1 to see if we are getting those networks up to Core Router 1. Show IP route. And we are getting the networks up to Core Router 1. So awesome. That's exactly what we want to see. We also, I do want to see, do show run BGP section. I don't need the do here. Okay, so it did take that aggregate address. All right, so we should be advertising our 192.168 network all the way up to our ISP routers. Let's check those real quick. So show IP route, and here we are. Yep, got it right here. Awesome. So we have our OSPF to BGP pretty much completely configured at this point. So we should be able from, well, I mean, I think I've already tried to ping from access router 1. It would work anyway. And so I'm gonna just wait till I get down to these access layer devices and we can test it from there. But yeah, so now I guess we can just configure DHCP. So let's go to, you know what, we'll do that in another segment because that's going to be a pretty long video as well. All right, hopping right on into our DHCP configurations. We're going to start off with, let's configure terminal, IP, DHCP, pool. And we're going to name this one clients 1. This is going to be client 1 pool. The network is going to be 192.168.10.0. All right, and the default router is going to be 192.168.10.1, and our DNS server is going to be 8.8. Okay, and now let's exit here and let's go ahead and say IP DHCP excluded address, and let's go ahead and set one for 192.168.10.0. say from 1 to 192.168.10. From 1 to 10. So, all right, and let's also do the same thing for 20. And let's do the same thing for 30. Oops. Okay. All right, let's do IP DHCP pool servers 1. And this network is going to be 192.168.10.0. 0. Oh, I'm sorry. I'm glad it rejected that. 20. All right. So default router is going to be 192.168.20.1, and DNS server is also going to be 8. Okay. Exit. All right. IP DHCP pool for we're just going to call it IoT or IoT Internet of Things 1, and this network is going to be 192.168.30.0. And our default router is going to be 192.168.30.1, and DNS will be again. Okay, and so that's how we're going to set up DHCP, and I don't want you to have to watch me do that over and over again for the other 2 routers, so I'm just going to go ahead and cut through that, and I'll get back with you as soon as I finish configuring it on the other 2 routers. Okay, guys. All right, here we go. We're getting started with our access switches here in our access layer. Getting started on access switch 1. We got a few things to configure here, namely the we're going to set up the VLANs, corresponding IP address from each subnet. We're also going to put our edge devices, assign them into a VLAN, and configure the trunk port to access router 1. And so let's get started with that. Over here on access switch 1, whenever we turn this on, it's something weird about these iOS images on GNS3. I've tried several different images. I've tried to do everything possible to try to fix this duplex issues, but it always says it's configured to auto, but in order for these error messages to stop, you just go in and explicitly set it to full duplex, and that should fix it for us. But we are going to get started with configure terminal and just say host name. All right. Show status. So you said it says auto, but it never works. Just say interface E00, and we're just going to say duplex full. All right, on interface 00, we're also going to say switch port. Trunk encapsulation WQ and switch port. port mode trunk. All right. So that sets up our trunk link between access router 1 and access switch 1, and then we're going to just create our VLANs. So we'll have interface VLAN 10 with an IP address of 192.168.10.5. Say no shut. They want to have interface VLAN 20. IP address 192.20.5. No shut. Have interface VLAN 30. 68.30.5. Exit. Okay, got our VLANs up, and they are. Wait, nope, we forgot to bring up interface VLAN 30. Okay, cool. All right, showing. We do have our trunk port set up, and even though we said full duplex, it still says auto. And what are we going to do next? Next, we're going to assign our the ports to our edge devices to its corresponding VLAN. So interface E01. This is going to be and interface E02. Oops. E02. So why doesn't interface E03 so why did those not exist? Did we not create those before? All right, let's see. Yeah, VLAN 30, VLAN 20. You spell VLAN right? VLAN. That's weird. So show. Okay, so now it says they're up. Well, that's what we want to see. So I think we're good here. I just want to check this client device real quick to see. Cool. We got a DHCP assigned address from our DHCP server in this subnet. So awesome. That's exactly what we want to see. Go ahead and do the same thing on server 1. DHCP. And IP DHCP. Okay, looks like we got our IP settings with the corresponding VLANs. Assign it just like we wanted it to. Respected our excluded addresses. Let's try to ping. Ooh, not print. Ping. Let's try something within the subnet first. Just say the 154.0.0.15. See if we can get there. Okay, cool. We got there. Let's try to ping the internet, something on the internet. Okay, we can reach the internet. That's cool. And let's try to ping. Let's see if our DNS settings work. Cool. So we are good there. That subnet is up and running just like we need it to be. And we're going to do the same thing on the other 2 subnets. And that is that, guys. Let's see. Alright. So we're getting this full duplex thing on access router or access switch 2 as well. So let's let's run through these real quick. Conft host name, access switch 2. Let's interface E00 duplex full switch port trunk cat.1q switch port mode trunk. Alright, interface E01. Oops. Nope. Interface VLAN 10. IP address is going to be 192.11.5. No shut. Okay. Interface VLAN 20. So IP address is going to be 192.21.5. No shut. And then interface VLAN. I'm interested to see if this one has that little quirk like the last one did as well. 192.168.31.5. Oops, forgot IP address. No shut. Alright, manual down. Okay. So E01 switch port access VLAN 10. So yeah, I did the same thing. All right. Interface E02. site. And interface E03. Right now, alright, so these two VLANs are up. Maybe it's just taking a second for VLAN 30 to come up. Just give it a few seconds, give it a few seconds. And there we go. Alright, good deal. So these VLANs are up. These client devices need to be bigger. So if we can get some DHCP addresses on them as well. Okay, cool. Client 2 worked. Check server 2. Awesome, exactly what we want to see. Let's check IoT 2. Good deal. Now let's try to ping across to, let's say 192.10.1, and let's see what that gives us. Yep, reach across the network. Good there with our inter VLAN routing. And well, let's try something on the same switch. So ping 192. What am I on? I'm on IoT 2. So let's try to ping server 2. That's going to be 192.168.21.11. Oh, I put 10.1. I was pinging the access routers. Wasn't actually. There we go. Okay. So yep, inter VLAN routing on the switch. So our router on a stick configuration is functioning just like it should be. And now finally, let's go to access switch 3. Maybe. Access switch 3. Access switch 1. Which one is this? This is access switch 3, alright. So conf t, name 3, interface E00, duplex full. I didn't say no shut on all of them. So, okay. Still waiting on VLAN 20 and VLAN 30 to come up. Alright, there goes VLAN 20. Should get VLAN 30 here in just a second. While that comes up, we're going to, go ahead and hop on our edge devices, edge nodes. Oops. Go. That there. Put on server 3. We're good there, and jumping on IoT 3. Come on. Uh-oh. So IP. Let's try one more time. May have a misconfiguration to troubleshoot. Alright, so let's check out access router 3. Also, let's just make sure back on access switch 3 do show. Sure, I did assign it to a VLAN 30. I did. Let's make sure do show VLAN 30 is up. VLAN 30 is up with the appropriate IP address. Okay, all right, next step, let's check out access router 3 up the line. Let's look at show. Sure our IP addresses are assigned correctly. So we do have, that's, you see the problem right there, misconfigured IP address. That's going to be our issue. So let's just say conft interface G 20.30. Now that should fix that. Okay, cool, that looks good to me. Let's go back to IoT3 and try again. Awesome. All right, that worked. Good deal. So that's going to do it for this lab, guys. And just a quick recap, in this lab we configured a complete BGP network to simulate an ISP environment, including the ISP exchanged. We configured a multi-tiered enterprise environment consisting of a core backbone layer, access layer routing, and access locations. This enterprise environment was also configured to be multi-homed, meaning we peered via BGP with 2 different ISPs. We did some traffic manipulation in order to steer our traffic toward our primary ISP and have the secondary ISP for backup. We configured some address summarization in order to summarize our OSPF network, both Area 1 and Area 0, and redistributed those from OSPF over to BGP. In our access network, we configured some DHCP to automatically assign IP information. We configured multiple VLANs and subnets to segment our network. We also configured some remote name servers in order to resolve domain names with our edge devices to be assigned via DHCP. And we also tested our edge devices connection to the internet. We also resolved some domain names in order to make sure everything was configured properly and working like it should. And so that's it for this one, guys. I hope you got value. All feedback is welcome, positive, negative, no matter what. If you have some feedback, please leave it in the comments. If you got any value from this at all, would hope that you'd like and subscribe. And until next time, guys, I hope you stay connected and keep progressing with whatever journey that you're on. Thanks again, guys. Bye-bye.